What's up, guys? Welcome back to Two Men, One Course podcast, a family-friendly podcast. I don't do anything inappropriate, but Tyler can do whatever he wants. But we try to keep our podcast family-friendly. And again, if you like us, don't forget to click like, subscribe, rate 5-star, make a comment, leave a comment, right, and tell all your friends about us. Yay! Tyler is not here today. It's just me. So he bails on me. Anyway, so he's not important. Don't have to care about it anyway. All right, so before we go further, let's talk about our sponsor that make this podcast happen. Here we go, Kraft Heinz Company. Right, the past couple weeks, so I'll talk about the ketchup by Heinz Company. Right, last week we talked about what? No, that's 2 weeks. Last week, 2 weeks ago, but what's up, that drink? Kool-Aid, also from Kraft Heinz Company. Okay, so these two are the founding father of Kraft Heinz Company. They merged, so two companies separately. They merged later in the sometime in 1900, early 20th century. Anyway, but from the merger, they are one of the best, the largest food and beverage company in North America. So the third in America, I think, and fifth in the world. Let's take a look at some of the top companies, right? So number one in the world, always Pepsi. No one taken down, right? Coca-Cola, actually number 8 in the world. Still good. I mean, not bad at all. These are the top 10. It's amazing. They bring a large amount of revenue. Okay. Number 2, so Tyson Food. You might recognize all the meat products, especially chicken. Okay, Nestle is, here we go. So all the cereals, coffee, or drink. All right. I don't know what JBS USA is. Kraft Heinz Company is at number 5th in the world. You probably are familiar with all this product. All right. So we have Capri Sun, Planters. That's all nuts product. Philadelphia. That's cheese. That's cream cheese right here. Kool-Aid, Golden Circle. What's Golden Circle? Is it chips? Maybe, I don't know. Don't really use that much. Ketchup, all right. What else? We have Lunchable, all right. You guys know what it is. Most of you, Velveeta, love cheese. Mac and cheese, love cheese. Oh my gosh. Maxwell, that's probably coffee. Okay, Jello. Anyway, so they sell a lot of stuff, all right. Kraft Heinz Company, and after the merger. So I mentioned from last time, so the home of Pittsburgh Steelers, so we call Heinz Field, right? Kraft did not have the naming right on the field. Okay, it still belong to Heinz Company. Okay. Anyway, so all right, now what you'll be doing in the lab? So listen carefully. So there are 2 parts total. The first part, the goal is to determine the heat capacity of calorimeter. Why do we need to do this? I'll tell you in a bit. Okay, but here's what we're gonna do. In part 1, you're going to prepare 4 test tube and 1 beaker. The first 2 test tube is just water, and the second test tube are the metal, different weight. Okay, and then you will set up a heating station. So we got ring clamp, wire, gauze. I put this beaker on there, add water. All right, and then you're gonna put all the test tube inside that beaker and heat it up. Put a thermometer in there, so just look at the temperature. Okay, it should be about 100 degrees. So slightly boiling water, and when everything has equilibrated, the temperature of the metal and the water inside the test tube 1 and 2 should be at 100 degrees as well. Right, but it could be 101, 102. It's fine as long as you know the initial temperature is good. That's all you need. Right. All right. Now you can do exactly like what you saw in the practice sample we did together in the previous video. Okay. So here is the calorimeter. So you take a beaker, right, or a styrofoam cup, either way, and then put another styrofoam cup on it. So you can have like a styrofoam cup and a beaker, or styrofoam cup on styrofoam cup. Either way works. Whatever you feel comfortable with, easy to access. You're gonna add 70 milliliter of water in it. Put the thermometer in it. Let's read the initial temperature. It should be about 23 degrees in the lab, right? About that. And then you're going to quickly transfer test tube 1. Don't touch it, use tongue. Now use tongue. And pour it into the calorimeter. Now, are you ready? So make sure you watch. All right, 1, 2, 3. Pour it in there. So you have more water in it, and the temperature changes, right? Hot water goes to cold water, so the temperature goes up, of course. Now according to the law of conservation of energy, so one loses heat, the other one gains heat. The hot water, that's from the like in the test tube, loses water, negative sign, and the cold water in it, that's positive sign. Okay, so all the heat from hot water goes to cold water. Here's a little bit different. In the practice problem we did together, we kind of simplify it, right? All the heat, of course, from the hot object goes to the water, just to the water. But in reality, not just this water, the whole water absorb energy. The whole calorimeter also absorbs energy as well. So you have to add the calorimeter term into it. Okay, so they also gain heat, right? Not just the cold water. Okay, all right, now, and then you're gonna just plug in the equation Q equal to ms delta T, so mass of hot water. So you need to know the mass of hot water. Specific heat capacity of water, hot water, cold water, same specific heat capacity. So temperature change, and same thing on the right. So ms delta T, this is all cold water, right? And calorimeter. Okay, now the calorimeter is very difficult to weigh 1 grams of calorimeter, right? So we get in this case, I mean mass. We're gonna use the heat capacity instead. We don't care how much is it, but we just assume the whole thing absorb the heat, right? So we use specific heat capacity, okay, and heat change, temperature change. All right. The whole goal is to determine the heat capacity of this calorimeter, right? So which means that if you want to solve for heat capacity of calorimeter, you need to know everything else. The mass of hot water and cold water, you weight it, right? So you just read the left hand out. You know how to weight it. And specific heat capacity of water, you can look it up from the table. And now the temperature change. Well, there are 3 temperatures. Do something with it. Yeah, you're gonna get everything except the heat capacity of the calorimeter, which we want to determine. Okay. That's the first trial. The second trial that you do with the test tube too, basically. So you do it 2 times, average it out. Okay. If you're not sure, you want to repeat the 3rd time, go for it. All right. All right. So once we have a heat capacity of water, here's what's going to happen. Okay. All right. Keep that heat capacity of water in mind. Oh, no. Heat capacity of the calorimeter, not water. So, all right. Now, part 2, determine the specific heat capacity of the metal. Okay, just like in the previous the example we did in the previous video, just like that, right? So we have calorimeter, got water in it, initial temperature. Quickly transfer, let's say test tube 3 first. All right, use tongue, don't touch it, it's hot. Put it in there, all right? So water level goes up a little, and the final temperature, you read the final temperature. Now you can, according to the law of conservation of energy, so heats out equal to heats in, right? So the metal loses heat, cold water, and the calorimeter gains the heat. Okay. All right, that's it. So specific heat capacity of metal can be determined from just this right here. Plug in the equation. So specific heat capacity equation, ms delta T, this is all metal. All right. On the right side, so heat capacity of water. Oh no, specific heat capacity equation of water. And the last one, the calorimeter, use heat capacity. Okay. Now, here's the thing. This is why we're doing part 1 first, determine the heat capacity of the calorimeter. That's because if you want to determine the specific heat capacity of metal, you need to know everything else and solve for this value, this term, right? Well, you also need to know the heat capacity of the calorimeter, right? So usually in any calorimetry experiment, the first step is to determine the heat capacity of the calorimeter used. Always, because you need to know that to be able to determine everything else. That's what the part 1 for. Okay. All right. So mass of metal and mass of cold water, you know that you can weight it. Specific heat capacity of water, you can look up, right? That's from part 1. Heat capacity of calorimeter is from part 1. And delta T, you know how to find delta T. So right here, TF, T initial, T initial here, so you know that. And you're going to repeat part 2 with the test tube 4. That's it. Okay, so basically 4 calorimetry. That's what you're gonna do. Should be quick, should be really quick, but you have to be careful, right? Transfer water or transfer metal, no water splash out. Everything has to be contained contained in the calorimeter. Okay. All right, now go to the fun segment of our podcast. So this one, autocorrect. Let's say the conversation between the two people. You home yet? I'm eating lots of peanuts. What? So you better stay away. What? Oh my God. Peanuts. Oh, that hurt. Okay. Next one. Are you definitely going to veterinary school? Yep. I'll get to spend my days humping animals, and that makes me happy. Wow. Helping. I definitely meant helping. I was so scared there for a second, man. Oh my God. All right, talk to Aaron. Can you pick me up some more boopsicles? All right, can you pick me up some more boopsicles? No, I meant boopsicle. Boopsicles. God donkey. So that's 3 orders of boopsicles and 1 holy donkey. Anything else? Nope. All right, so we have fun segment, but Tyler is not here, so we're gonna keep the question for him later for next week. But we got one question asking what's the question? Let's say, what is Tyler? What's that? Snapchat. All right. So Tyler's Snapchat is right here. Okay. If you want to contact him, go for it. That's his email. Ask him anything. So he's a pretty fun guy. All right. Okay. So that's it again. So thank you for supporting our podcast. We won't make it this far. So 7 episodes so far. We won't make it this far because of. Is it not because of you guys? You're our fan. We are so lucky to have you. Anyways. Again, if you like us, don't click. Make sure you click like, subscribe, rate 5-star, leave a comment, and tell everyone else to watch our podcast. Okay. All right, that's it. And if you don't have any questions, well, I'll see you guys later next week. Peace.